Stationary points with curve sketching. The derivative is used to calculate the stationary points on a curve where the gradient is 0. In other words, we look for where dy dx is 0. There are three types of stationary point. We have the local minimum, the local maximum, and the horizontal point of inflection. We can use the sign diagram to classify the stationary points already identified. So we identify where they are using this, and then we can use a sign diagram to classify them into one of these three. So locating stationary points of a polynomial function. Let's look at how we do this. At local maximum points and local minimum points and points of horizontal inflection, the gradient of the curve is momentarily 0. Now we discuss that up here. So the gradient function here, dy dx, would be 0. As we pass through a minimum turning point in the direction of increasing x, the gradient changes from negative to positive. So this is a picture of a local minimum. We can see the gradient is negative along here. It becomes 0 at the turning point itself, and then it becomes positive. So the gradient function, f-dx or dy dx, goes from negative to 0 to positive as we pass through the turning point. As we pass through a maximum turning point in the direction of increasing x, the gradient changes from positive to negative. So a maximum turning point looks like this. To the left of it, the gradient is positive. The gradient is 0 at the actual turning point itself, and then becomes negative. For horizontal points of inflection, the gradient, though momentarily 0, does not change in sign if we look either side. So a horizontal point of inflection looks either like this, where it goes positive and it becomes 0 in the middle here somewhere, but then it goes positive again. Or it may come downwards this way, in which case the gradient is negative, becomes 0 in the middle here somewhere, but then continues to be negative once we're past the 0. There are 4 basic steps. Find the derivative of the function, so that's f-dx or dy dx, depending on the notation you're using. Find the values for which dy dx is 0, or f-x equals 0. So that locates for you the turning points themselves. So that will locate for you on this diagram whereabouts this horizontal point of inflection is. Find the y values corresponding to the x values, so that gives us the coordinate rather than just the x value here. And then draw a sign diagram to determine the nature of the stationary points. Now the way that you do this is, at the top here we have x, and the coordinates of the stationary value itself go in the middle, and then you take an x value that's to the left of that. So in a particular case you'd actually write numbers here, not these words, and you take a point to the right, and then you look at dy dx. Now you know that dy dx is 0 at the actual stationary value. That's the whole point. Now let's suppose here we took a point to the left. Let's suppose this was 2. Take a point to the left like 1. The only thing you have to be careful of is that you don't go past another stationary value. So point to the left. Let's suppose that turned out to be positive. And we took a point to the right, say 3, and that turned out to be negative. Then positive gradient, 0, negative. That would tell us that we had a local maximum.